Right, we're going to move on to... By the way, Dinesh got a mug at the Christmas BettaKultcha. That's why I didn't give him one. I hadn't forgotten. We're going to move on to Dr. Chris Empson. Now, Chris presented at the Christmas BettaKultcha, but we had a slight technical problem with his slides, so we've invited him back to see if we can run it smoothly this time. It's a fascinating presentation, so get your thinking caps on. You have to concentrate for this one, and I'm going to ask hard questions afterwards, all right? So let's give it up for Dr. Chris Empson!
Ready? Okay, so tonight I'm going to take you to the very frontiers of human understanding. I'm going to talk to you about a particle physics experiment that appears to show that light isn't actually the fastest thing in the universe after all. I'm going to do something really unscientific at the end, and I'm going to offer you my opinion about it. So in 1905, this is Albert Einstein, if I can say it right, and he published his theory of special relativity, which said that light was the absolute fastest thing in the universe, and nothing could go faster than it at all. That is how fast light goes, and it's so fast that light could travel twice around the equator of the Earth in the time it takes you to blink, which is incredibly fast, I think you'll agree. So what's light made of? Well, light is just made out of little tiny particles called photons, and they're one of the family of particles that make up what we call the standard model of physics. But I'm not going to talk to you about photons tonight. I'm going to talk to you about neutrinos. They come in three flavours, the electron neutrino, the muon neutrino, and the tau neutrino. Now, what is a neutrino? So it's as near to nothing as you can possibly get. They're absolutely tiny, they've no electric charge, they've virtually no mass, they don't really interact with anything, so they're very hard to detect. But you can detect them, and oh yeah, I've skipped a slide, I'll go back. They're produced in the sun, 60 billion of them travel out of the sun and through every square centimetre of your body every single second, but you don't feel them because they don't interact with your body. So this experiment in Japan is called the Super K experiment, and it was built to detect these neutrinos coming out of the sun. Every so often, one of them will interact with the 50,000 tons of super pure water in here, and it'll make a little tiny flash of light, which is detected by the little yellow blobs. And this is another detector in Italy that does more or less the same job, and this is called the Opera experiment. But it doesn't use neutrinos from the sun to look at how these neutrinos behave. It uses neutrinos coming out of the Large Hadron Collider, which you might have heard of. It's been in the news quite a lot like recently. And they fire protons around this big ring, which is about, well, it's huge. It spans the French-Swiss border. They accelerate protons to 99.99999% of the speed of light, collide them together to recreate the conditions just after the Big Bang. And they can smash these protons into a big block of metal, and it produces a shower of neutrinos, which they fire through the Earth's crust to this detector in Italy. It's 450 kilometres. It's all timed and coordinated by the clocks, the atomic clocks in GPS satellites. It's a really high-tech experiment. But they ran the experiment and they were baffled because these neutrinos appeared to arrive 60 billionths of a second before they should have done. As if, so light would have taken 60 billionths of a second longer if it had been travelling through the Earth than these neutrinos. So they were baffled. But so how sure are they that they've got these sums right? Because this appears to contradict Einstein and his theory of special relativity. Well, they're 5 sigma right. They're 5 sigma sure that they're totally right, which is the equivalent of chucking a coin up in the air and it landing heads 20 times in a row, which would take you 7 weeks if you tried to do it yourself, which I wouldn't recommend. It's the equivalent of saying, so what does this mean? So it's the equivalent of me throwing a ball at Richard down there, and the ball arriving before the light that allows him to see it arrives at his eyeballs. So to Richard, the ball would have travelled backwards in time, which is very spooky. So it's all very odd. So what could be happening here? Well, it could be that the neutrinos are travelling through some extra dimensions in space-time, so they're actually appearing to go faster than the speed of light, but they're not actually. But the standard model doesn't predict these, but string theory does, so we can't discount them totally. But maybe, it could be that all of the physicists in Italy were drinking too many espressos and everything just appeared to be going like really, really, really fast. But the speed of light is invariant with respect to the caffeine intake of the observer, so that's not And also, we've never ever seen an event happen before the thing that caused it. The classic example of this is someone travelling backwards in time to kill their grandparents before they've given birth to their parents, thereby making their own existence impossible. And also it contradicts observations of this supernova, which exploded in this massive Big Bang, not a Big Bang, not the Big Bang, but a Big Bang, and releasing a shower of neutrinos, which we detected on Earth just before the little flash of light, well, the big flash of light, that caused the explosion. So that contradicts this experiment in Italy and its observations. So really, I think someone's got the sums wrong. I think someone's made a cock-up. And I think it's going to be proved through peer review and the scientific process that's carrying on at the moment that actually Einstein was right. And I think you'll probably, I hope you've got some more interest in following the story too. Okay. Thank you very much.
Dr. Chris Empson.